Good morning friends. In this lecture I am going to discuss a new concept students. In the concept we mainly discuss 3 points students. First one is divergence, second one is physical interpretation of divergence, and third one is solenoidal vector. What students? Solenoidal vector. Let us see the concept students. Del applied to vector point function. What students? Del applied to vector point function. Now in previous classes we discussed del applied to scalar point function students. There we get gradient. What students? Gradient. Now here we get divergence and second one is curl. What students? Divergence and curl. Important topic students. Now in this lecture I am going to discuss only divergence. What students? Divergence. Now let us see the definition students. Divergence of a vector. Let f bar be continuous differentiable vector point function. What is f bar students? It is continuous and differentiable vector point function students. The divergence of f bar is denoted by, students simply div, div f bar. Okay students, or del dot f bar. Okay students, it is denoted by del dot f bar, and it is defined as del dot f bar, that is equal to I bar dot dou f bar by dou x plus j bar dot dou f bar by dou y plus k bar dot dou f bar by dou z. Once again students, important, I bar dot dou f bar by dou x plus j bar dot dou f bar by dou y plus k bar dot dou f bar by dou z. This can also write as sigma I bar dot dou f bar by dou x. Once again students, important, sigma I bar dot dou f bar by dou x, because we are using this notation further concepts. So please remember this one also students. Okay, right. Let us say note students, if f bar that is equal to f1 I bar plus f2 j bar plus f3 k bar. Okay students, you define f bar now. So f bar as students f1 I plus f2 j plus f3 k bar. Now I want to find del dot f bar students, del dot f bar. So dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Simply you differentiate partially f1 with respect to x students, f2 y, f3 z students. How can you get this one students? How can you get this? Simple students. What is del students? Del dot f bar. What is del students? I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z dot f bar students. F bar is f1 I bar plus f2 j bar plus f3 k bar students, f3 k bar. Now we know students I bar dot I bar. What students? I bar dot I bar 1. J bar dot j bar, value also 1 students. K bar dot k bar, value 1 students. Now rest of the value students like I bar dot j bar, I bar dot k bar, all the value students 0. So I bar dot I bar students we get 1. So dou f1 by dou x. In this way we get dou f1 by dou x students. Similarly dou f2 by dou y, dou f3 by dou z. Now whenever you find del dot f bar, okay students, you simply write dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Okay students, for example say f bar is xi plus yj plus zk students, zk. I want to find del dot f bar students, del dot f bar. Now here you don't write I bar dou by dou x plus j bar dou by dou y plus k bar dou by dou z dot say xi plus yj plus zk and then apply formula. Don't do anything students. Simply do here dou f1 by dou x. Okay students, that means you differentiate this partially with respect to x students. So we get here dou by dou x of x is 1 students plus similarly dou f2 by dou y. That means here dou by dou y of y students we get 1 plus dou by dou z of z is also 1. So that is equal to, we get here students 3. Okay students, once again you use this formula students whenever you solve the problem students, whenever you solve the problem. So del dot f bar, that is equal to dou f1 by dou x. That means dou by dou x of x we get 1, dou by dou y of y students 1, dou by dou z of z students we get 1. So simply add them, we get 3 students. And if you observe the result students, we have magnitude, that means it is a scalar. Okay students, it is a scalar. See here students, del dot f bar is a scalar. What students? Del dot f bar is scalar. Now let us see the physical interpretation of divergence students. What students? Physical interpretation of divergence. Suppose there is a fluid students, fluid flows here like this. Okay students, in this direction it has students, it has velocity students, velocity. So he defined velocity vector students. Okay students, velocity vector as v bar, that is equal to vx I bar plus vy j bar plus vz k bar students. Okay students, fluid has the velocity. He defined vx I bar plus vy j bar plus vz k bar students. Now simply you find here div f bar students or del dot f bar. Now by using this formula I get here students dou by dou x of vx plus dou by dou y of vy plus dou by dou z of vz students, dou by dou z of vz. We know dou vx by dou x students. What is dy by dx meaning students? Meaning rate of change students, rate of change. Here where we have rate of change students? In the fluid, in the fluid students. That's why the physical meaning students here, rate at which fluid is originating at a point per unit volume. Once again students, rate of change at which fluid is originating at a point per unit volume. This is the physical meaning of divergence students. Once again, that means here the amount of a fluid is enter into one phase and leave or out another phase students, another phase. Now say at a point P, okay students, the fluid enter, okay students, the fluid out students, the fluid out. Okay, the quantity is calculated here, divergence, the rate of change. What students? The rate of change, the rate of change at which fluid is originating at a point per unit volume students, per unit volume. This is the physical interpretation of divergence students. For example, see students here, here water enters students certain quantity and the enter and out also the same amount out students. The amount of fluid which enters and the same amount is out students, the same amount is out. That means there is a divergence is 0 students. Okay students, the divergence is 0. So solenoidal vector. What is solenoidal vector definition students? If del dot f bar that is equal to 0, then f bar is called solenoidal vector. What is solenoidal meaning students? The fluid, amount of the fluid enter, okay students, enter, the same amount is out students, the same amount is out. Okay, there divergence f bar, divergence of f bar value 0 students. In this case f bar is called solenoidal vector. What students? Solenoidal vector. Once again students, what is del applied vector point function students? Divergence and curl. Okay, what is definition of divergence students? I bar dot dou f bar by dou x plus j bar dot dou f bar by dou y plus k bar dot dou f bar by dou z. Simply it is denoted by students sigma I bar dot dou f bar by dou x. Okay students, always del dot f bar is scalar students, scalar. Now what is physical meaning of divergence students? Physical meaning, okay, the rate of change. What students? The rate of change which fluid is originating at a point per unit volume, per unit volume. Okay students, right. And then solenoidal vector students. What is solenoidal vector? Del dot f bar is equal to 0. What is physical meaning students? Which the amount of fluid enter, the same amount is out students, same amount is out. Okay, in such cases f bar is called students solenoidal vector, solenoidal vector. That means in this case what happens? Del dot f bar is equal to 0. Okay, okay students, in the problem he given f bar, okay, show solenoidal vector. That means you find del dot f bar value, students 0, del dot f bar value is 0. Okay, hope you understand students. Please subscribe this channel, like this video students, share this video students. Thank you for watching this video. Jai Hind.